to be a pretty easy section for you. It's about domain and range. Does anybody have a good definition of domain? What is it? It's the x's. It's the values of x. And if domain is the values of x, what must range be? Values of y. When you talk about domain of a function, you use either two forms. You use set builder, which is inequalities, or you use interval notation. IXL is using nothing but inequalities for this section for y'all. So we can talk about everything with inequalities. We're going to do both domain and range on these. It talks about, the question just says, what is the range of the function? We're going to go ahead and do domain and range. I'm doing both. When I think about domain, I think literally about the x-axis, and I just kind of look at the function. This function doesn't move to the right at all, does it? Is there anything drawn on the right-hand side? Everything's kind of drawn on the left-hand side. And it looks like the drawing of the function actually starts when x is what? 0. And the function has a y value when x is -1. It has a y value when x is -2, -3, -4. So the deal is x has a relationship to 0. What is x's relationship to 0? Less than or equal to. Now, IXL uses set builder notation, so I actually kind of write it like this. It's called set builder notation. Just wrap it in curly braces. All values of x such that x is less than or equal to 0. Now, as far as range, it's kind of the same idea. And notice what I did is I read domain right to left. Actually, never mind. We're not doing interval notation. When it comes to range, we think about our y values. What's the lowest value that y actually achieves? Does it achieve 0? I know it's kind of small. I was trying to save paper, believe it or not. Does y achieve the value of 0? Isn't y touching right there? Or is that just me? Isn't it touching at the origin? Does y achieve the value of 0? Does it achieve a value of 1? Maybe 2, maybe 3 over here somewhere. And does it keep going up for all of its life? So what's the relationship with y? Greater than or equal to 0. You use set builder notation. All values of y such that y is greater than or equal to 0. A1's a pretty easy section if you can read graphs and you understand domain and range. It won't take you long. This is a graph of absolute value. Aaron, what's the domain of that graph? That's 100% right. Deal is, okay, Aaron said this because she remembers interval notation. I didn't see it using any interval notation. I'm not saying it won't, but I did probably 30 or 40 and I never saw it use interval notation. What it's going to say is all real numbers. It's every number that exists. From negative mean to positive mean means all real numbers. Of course, they won't use the number symbol. But all real numbers. Lindsay, what's the range of that function? Y is greater than or equal to 0. All values of y such that y is greater than or equal to 0. And you'll do a couple of easy ones that are more or less kind of centered around the origin. And of course, I've changed it up a little bit and start moving functions around. I have to. Now this one has actually a dashed line on the y-axis. Does anybody know what that's telling you? dashed line is what we call an asymptote. Saying the function does not cross that line or touch it. It's what we call a vertical asymptote because it goes up and down. It's vertical. The function will never ever touch that line, ever. So while it might look like there is something when x is 0, is there? No, because that's where that asymptote is wrong. X never gets to achieve that value of 0, but it gets to be bigger because isn't it growing to the right? So what would the domain of this function be? X is greater than 0. All values of x such that x is greater than 0. How about range? Asymptotes are kind of funny. They're literally like jumping off a cliff. As soon as this function gets close to this asymptote, it immediately just jumps off a cliff. But it falls for the rest of its life. I mean, it's literally going down forever. Okay? And you know, some kids are tempted to say, but this piece kind of quit growing. No, it's just growing really, really slow. Kind of look at this thing. Is it increasing as you move right? Will it do that for all of eternity? So what's the range? Yeah, I'm glad you're using interval notation. I am. I'm just telling you, I did a bunch of these. I never saw it used. So let's use set builder. Oh, actually, we can't use set builder. We have to use words. What are the words for negative infinity, positive infinity? All real numbers. We'll do one more with a graph, then we'll go to the ones that don't have graphs. Okay. So we're tasked to find the domain of that function. It's probably a square root function. Looks like a square root function. And we'll start with domain. Notice that's a solid dot too. That means that point exists. So what's the smallest value of x? -6. And then we get to be -5 and -4 and 0 and all that good stuff to the right. So Hanukkah, what's our domain? It wasn't Hanukkah, but I think I heard it. Greater than or equal to -6. You know, we got to be -6, we got to be -5, we got to be 0, we got to be everything greater than or equal to -6. Asia, can you give me the range? We'll try. I would say get your eyes checked, but you're already wearing glasses. So, can't say that. Help her out. What's the smallest y value? 3. That's your smallest y value, Asia. I hope you're looking at the right graph. Right here. Halfway between 2 and 4 is 3. Do we get to be more than 3? So what's the range? You got it. All values of y such that y is greater than or equal to 3. Now I'm going to quit doing the graphs. I don't remember what point scale it was. Remember when you got in the 40s or 50s? It got to the point where they weren't giving graphs anymore. I honestly don't expect any of you to remember what the graphs look like. It would be nice if you did. This is absolute value of x. It looks like that. That's what it looks like. Now, I guess if you don't know that, most of you are using your phones to do everything, aren't you? What I would do is I would go to a site like desmos.com, and I'll write that on a piece of paper, but it's desmos.com. That's the website, desmos.com. And they have a nice graphing calculator there. And you can see your grid here, obviously. And here's where you type. I'm going to click over there. I guess you'll tap with your phone. And I can raise the keyboard up. This is what absolute value of x. It's right there above ABC on a laptop. And there's the graph. Okay. Now this one I left the choices on. It's multiple choice, but that's what the graph looks like. If we go back and look at our choices, what is the range of that function? Which choice? A, B, C, or D? It's C. Always 0 or higher. Anybody any questions so far? There are a couple where you have to literally sit down and look at a graph, kids. If you don't remember what something looks like, you'll have to graph. You've got TI-84s, you've got desmos.com. I'm sure there's other stuff out there. That one. I don't want to do all of these because it's kind of a waste of time. But the idea is just look at a graph. I'm going to do the one with the square root. Y is the negative square root of x plus 4. And I'm going to switch on over to Desmos, type that thing in. So I'm in the negative key, square root. I don't think Desmos requires you to use parentheses or anything. I think you can just type it in. That was plus 4, wasn't it? You can use parentheses if you want, but Desmos will keep it under a radical until you arrow out of the radical. Please get off your phone. There's what she looks like. Now the question was about domain. Bryce, what's the domain of that function? I don't know, I called on Bryce. Bryce says B. You guys agree with him? Try to get to the point though where you don't have to look at the choices first, kids. Okay? That's where you need to get to. Get to the point where you don't have to look at the choices. But it is B. X is always greater than or equal to negative 4. The other one I want to look at is the one with the logarithm. There's actually 2 logarithms. But I'm going to look at this one right here, the last logarithm, because it's domain and range. That's what you start seeing when you get into the 90s. You start seeing where they ask for both pieces. What is the domain and the range? So we'll look at that one. And Desmos is pretty easy to use. Now, you don't actually see on Desmos a log button until you hit functions. So I'm going to hit functions. Oh, apparently I'm wrong. Sorry, you don't even have to do that. It's a logarithm, right? You just type log. It'll figure the rest out. Log of x minus 6. And that's what she looks like. Kind of zoom out for you. And notice how this graph just kind of disappears down here. I think it was the second example I did today. Desmos won't show this, but there is a what we call a vertical asymptote here that the function never ever gets to hit. The function is literally disappearing because Desmos can't plot a point anymore. It is falling forever. The function does continue to fall for the rest of its life, but there is a vertical asymptote here. That vertical asymptote's happening at 6. Okay? Are we allowed to touch that line? So x can't be 6, but can it be everything above? So we kind of focus on your domain. If x can't be 6, but it can be anything above, doesn't that leave you to choice A or choice B? Then we get to focus on range. And Desmos and even a lot of your TI-84s will not kind of graph logarithms 100% correct. They can't do it. But I am sitting here telling you that this thing falls forever, because I promise you it does. Is it also rising forever? So what's our range? All real numbers. So I think our choice on this one would have been B if you're looking at home, if you're looking at it. So if you go back to our little piece of paper, choice is definitely B. All right, A2, identification of functions is what's up next. It's a nice easy one. You could probably do this one in 5 minutes flat and get to 100. Anybody know the definition of a function? No one ever does. Function is a relationship between an independent variable. Nice if you could see some of that. A relationship between an independent variable that we call x and a dependent variable that we usually call y. I'll pause for a second. A relationship between an independent variable x and a dependent variable y, such that for every x, there is only one y. That's the long mathematical definition of a function. Anybody remember the definition you're supposed to remember? X can't cheat. For every x, there's only one y. X can't cheat. Y can, x can't. Now, most of the stuff you do under this section, if not all of the stuff you do under this section, you have a graph in front of you. So you use what's called the vertical line test. Vertical line test says a relationship, if I could spell, a relationship is a function if a vertical line intersects only once. Because if it hit twice or 3 times, x would be cheating on a y value. And these are all like yes/no questions. Is it a function? Yes, no. It's pretty simple. It gets a little harder where you have to pick out which one is a function, but it's pretty simple. So if I was to imagine myself drawing vertical lines on this example right here, would it be a function? Yes, they only hit once, kids. That's a function all day long. And you guys are old enough where you shouldn't actually have to do this, but some of you will. It's just the way it is. Has everybody got their notes down? Can I move forward? I saw a nod. I didn't see any no's. How about this guy? Is that a function? Bren says it is. He's right. Some of you are seeing that dashed line and like everything just went crazy and dark. It's a function. That's an asymptote. Who cares? This is a function. Vertical lines only hit it once. So yes, Haley Dick is the next one a function. No, God no, it gets hit twice. X is cheating. It has two y values. Then as you move on up, they'll start throwing things at you like holes in graphs. I don't remember talking too much about this last year, but that's a hole in a graph. There is nothing there. There's absolutely nothing there. It's just drawn so that you know that it gets really, really close. It's kind of like you need an endpoint to draw. You need 2 points to draw a line, right? Well, those are kind of the endpoints, and they don't exist, so we leave them open. That's all they are. They're just there for drawing assist and to let you know that it gets really close, but there is absolutely nothing there. So even if I drew a vertical line through those two open holes, would I actually be touching anything? No, there's nothing there. So is this actually a function? Yeah, it is. And you'll have to be a little careful with little screens on your phone, because there are undoubtedly kids who would think that this one is a function. But those aren't open holes, those are closed dots. So what happens if you draw a vertical line through those two closed dots? Touch twice, don't you? Function or not? It's a no. I think once you get in the 80s or maybe the 90s, they start throwing this at you. It might be in the 70s, I don't know, but it's basically multiple choice. Is a circle a function? No. How about the next one on the right? Is that a function? Some kids will pick it by accident, but it's not. You know, all they see is that open hole and they forget about looking a little prior to it. Hit twice. How about the one down here in the left-hand corner, lower left-hand corner? Is it a function? No. I see it pretty quick. It's right there. It's twice. And I guess by elimination, without even looking at it, it's got to be the last one. And that's A2, and it'll take you all of about 5 minutes. It won't take too long. All right, now we're moving on to A3, evaluating functions. And this is that blasted function notation that funks with your little heads, and you get a whole bunch of questions funkin' wrong, and you get funkin' frustrated, and you actually say the funkin' word. But I didn't. Don't try that. Use the following function rule to find f of 120. Can somebody tell me what that means I do? What you got, Brenton? Plug it in for x. Okay. This means let x, or let's say the variable. They're not always x, or are they on it? Yeah, we'll say let the variable be 120. And when you talk about this, like this f of 120 means find the y value when x is 120. That's all you're doing. You're just plugging in a number. Obviously, you can use a calculator on this. Some kids have to. I wish you wouldn't, but it is what it is. It really is at this point in time. But f of 120 happens when I replace that x right there with 120. This one's the first example. I mean, you're supposed to be able to do the first example without a calculator. What's 120 divided by 4? 30. Plus 5. 35. Just plug in numbers. Then as you move up, of course, they make it a little harder because they are hoping that you're doing this without technology. They really, really are. You know, you're going to plug in a 9. Find f of 9. -4 minus twice a 9, all squared. And I would like to do that by hand. Maybe, I don't know. What's that twice the 9 give us? 18. So -4 minus an 18 all squared. Can we do our squaring yet? No. We could do the FOIL method, but that would be really stupid to do. There's work we can do. What's -4 minus 18? -22? When you square a negative, what's it automatically going to become? You know, there's no point in even worrying about a negative symbol. You got to figure out what 22 squared is. Anybody know it off the top of your head? Well, you guys are actually going to work it out by hand. Yeah, 44. You guys gonna have any problems with that? Just plug in numbers. And if you got to use a calculator, I guess you got to use a calculator. Just be careful about how you use your calculator. This is absolute value. I'm going to get a TI-84, just, in case you are that kid who has to use a calculator. Calculator actually has absolute value on it. Does anybody know where it's at? It's in math, according to Brenton. But we have 8. I'm going to go to math. Get this where you can see it. I typed in the number 8. Hit the math button. How about after that? Num. Num for number. Okay. Absolute value. It's first choice. And I have a -11 plus x. And x is what in that example? 3. 64. You've got to use a calculator. Your calculator can do it. I mean, just Google it. Like, type in TI-84 absolute value, and guess what you'll find? How to use absolute value on a TI-84. There isn't much these things won't do. All right, so once you get into maybe the 80s, you start seeing things like this. Use the following function rule to find g of -6y. And you've done all this work to get there, but then you get here and you just thought the world just ended, like everything changed. It's the same deal. What do you let the variable be? Yeah, it's the same thing. Plug in, replace. Who cares? It's not necessarily a number anymore. Just let the variable be -6y. And the function is actually called g composed of m, or g of m. And we're going to replace that m with what? -6y. So what is g of -6y? According to Brenton, it's 18 y's. And then, of course, you'll kind of get accustomed to just plugging one thing in, kind of, because that's just one term, and they'll up it a little bit. And now you're going to find g of q plus 7. Has the concept changed? No. What do you do with q plus 7? You plug it in. Nothing has changed, kids. We're going to take that q plus 7. We're going to put it right there with w. I'll write this one out. 4q plus 7. It's 2 or more. I route. -6. No, I can't read. What is 4 times q plus 7? 4q plus 28. Going to take away 4 from that, and what's our result? That's 24. It doesn't get much harder than that. It really doesn't. They'll start introducing exponents in the 90s. This is g of -8d. And you're supposed to replace f in this case with negative 8d. Now, there will be at least one kid in here that does this. G of f is negative 8d squared. What did that kid do wrong? And they forgot parentheses. They didn't actually do the replacement either. They really did not. All of this goes in for f. So all of it must be what? Squared. That's just wrong. What is a negative 8d all squared? 64d squared. That's not too bad. I'm going to go ahead and do the last two just to get them done. Not necessarily difficult. G of 8t, remember we got to put it in two different places on this one. You got a trinomial in front of you. There's actually two places where you have to plug it in at. We're going to have to square it. Then we're going to have to add to that the product of that 8t and 9. And then take away 6. Does everybody understand what happened there? The simple substitution property. What do you get when you square that 8t? You get 64t squared. How about 9 times 8t? 72t minus 6. Now, a couple of my Algebra 2 kids want to put this kind of stuff together still. Like, whatever. Don't try to be that kid in pre-calc. That's what bridge math is for. You can't put those things together, you know that. And here's about as hard as it gets. I actually think this problem showed up at a 96. But, you know, there's a reason that it's up there because kids will undoubtedly mess this up. We've got a b minus a 4 squared minus a 5k. What is b minus 4 squared? That's exactly what it is. Oh, I don't know why I wrote that k down there. Sorry. I want to talk about this. I know at least one kid in this room was thinking b squared minus 16. I've done this for years. Somebody was thinking it. That's the devil's work, kids. There's a meme about that. You got to write it twice and do what? FOIL. That's how Erin got her result. She wrote it twice in FOIL. Or she wrote it twice in her head, but it was written somewhere. You got to write it twice in FOIL. So b squared minus 8b plus 16, we do the distributive property, minus 5b plus 20, and we just combine our likes and we're done with this thing. Looks like there are negative 13 b's, and 16 and 20 makes 36. And that will get you through 3 easy sections of IXL.